Hi, and welcome to the Animal Training Academy podcast show, the show for animal training and behaviour nerds, where I, Ryan Cartledge, interview the world's most proficient animal training and behaviour geeks. We're absolutely thrilled and grateful to have you here with us today. So make sure you hit that subscribe button on whatever you're listening to this on so that you don't miss a single episode. Each episode of this show is brought to you on behalf of the ATA membership. And if you like the conversations in this episode, then you're invited to continue them with like-minded behaviour nerds within the membership area, which you can find out more about at www.animaltrainingacademy.com. You'll get access to twice monthly live web classes, the back catalogue of previous web class replays, plus a huge library of videos and projects to help problem solve your training challenges. Plus, we're a sociable bunch with an exclusive private Facebook group and forum areas. It's like a Netflix social media platform for animal behaviour geeks. But we will get started on today's episode where we'll be talking to one Chris Varnon. Dr. Chris Varnon is an Associate Professor of Psychology at Converse College, specialising in behaviour analysis and comparative psychology. He received a BS from Jacksonville State University in biology and psychology, and then he completed an MS in behavioural analysis from the University of North Texas, followed by a PhD in experimental psychology from Oklahoma State University. Dr. Varnon has a passion for all things animals, and especially animal behaviour. His research has involved a diverse range of species, including horses, rats, pigeons, rattlesnakes, turtles, cockroaches, and bees. He is especially interested in learning in non-traditional species, such as reptiles, amphibians, and invertebrates, and how learning interacts with social behaviours. Most recently, Dr. Varnon has become interested in using insects as behavioural and biological models of substance use. So without further ado, it's my very great pleasure to welcome Chris to the show today, who's patiently waiting by. Chris, thanks so much for taking the time to come and hang out with us here at Animal Training Academy.
Of course. Thanks for having me.
We haven't geeked out on invertebrates before.
Yeah, that's a little, it's a little bit of an atypical species for behavior analysis, or group of species.
Not interesting, it's obviously interesting, but an exciting one. I feel like scratching the surface and kind of starting to break down some myths and beliefs via some of the stuff that we've been seeing over the last decade. Part of that's been your contribution to our understanding in science. So yeah, I'm kind of embarrassed, I don't know if that's the right word, that it's taken us 140 episodes to really explore.
I would say to get here in 140 episodes is very progressive. This is really like getting into like the weird areas of what you're going to see in animal behavior and behavior analysis. So you're ahead of the curve, man.
Well, it's aligned so beautifully with my internal non-spoken really thought process and goals with Animal Training Academy to demonstrate the laws of behaviour being applicable for all earthlings, cockroaches, bees, rattlesnakes, humans, dogs, horses, whatever we're talking about. So it's a no-brainer to me. It's obvious that the laws work, and something that you've done is figure out ways of doing studies to gather data about these species, which I'm excited to hear in your words, straight from the horse's mouth, about that a little bit later on in the show. But Chris, we like to learn about people's journeys in the show and how they came to be doing what they are currently doing, and a little bit about their journey. So I was wondering, to get us started, if you could just take us back and share with us that journey and where your interest in animal behavior started.
I mean, pretty much. I knew I was always interested in animals. I grew up in a very rural area where it's like 30-minute drive to a grocery store. I mean, it's out there. And so to entertain myself, I had me, and I had my dogs, and I had, whatever stuff was outside. And so I was just running around with my dogs, looking at, whatever animals were out there, running around and, in the creek and getting in trouble and stuff. And then when I was getting my undergraduate degree, I thought, okay, I love animals. I especially love herpetology, which is reptiles and amphibians. So clearly I'll be a biology major, right? That's where you go for that stuff. And that was fine. That was great. And then as I was doing that, or maybe even a little bit before, my mom brought home chickens one day. And I was like, the people at work had chickens. And I was like, okay, fine. I guess we have chickens now. We have everything else. It's fine. And I started getting really interested in just watching the chickens and what they do. And you're talking about misconceptions. I think, like we have an idea of like, well, chickens are not very, intelligent or whatever. They actually, I mean, I would say they're pretty smart for what they are. And I'm using smart, in an informal sense. It's hard to operationally define that. But they have like tons of different vocalizations. They have a vocalization that means there's a predator attacking from the sky. Everybody go hide under something. They have a vocalization that means there's a predator attacking from the ground. Let's all freak out about it for a while. The roosters will do a call that says, hey, here, I found food. Ladies, here's food. Would you love me if I give this to you? They have a call that means, hey, here's a good spot to lay an egg. You should have a nest here, and I'll be the dad of these babies. So there's like a lot of really complex stuff, and just like following them around in the woods and watching them, do stuff and interact. That's where I realized it's not just animals, it's animal behavior. So it sort of opened up a new venue for me for something I just sort of knew my whole life, is I like learning about animals. Now I also knew another word to it, right? I like learning about animal behavior. And from there, I started double majoring in psychology. And the program that I was at Jacksonville State University was pretty, behaviorist friendly. We had a lot of behaviorist people. So I just sort of fell in with some of those. Some of those faculty, learned a lot of stuff. I was doing some volunteer work for Bill Pallia and editing conference videos for him. So I was getting to see, without going to the conferences, all these really cool speakers talking about behavior analysis. And then it just sort of made sense to me, and it's something you can use a lot. Around that time, I started working at a zoo in Alabama, because I thought, hey, that would be a cool way to be around animals and behavior. And it was like a 2-hour drive from my house, but I was doing that like 4 or 5 days a week. And that was really fun. And I got really into that. And the issue I had when I was graduating was that when I first started, I just knew, I don't know, something about animals. And then by the time I was graduating, I had too specific of a focus. I really wanted to solve some specific problems with birds at zoos. And so when I went to look beyond my undergraduate degree, I was like, well, it has to be this problem or else I'm not doing it. And, there's not always a lot of people that want to solve the problem you want to solve. So I was having a hard time finding different programs. And eventually I came across the program at University of North Texas Department of Behavior Analysis. And I started talking to Jesus Rosales about some of this stuff. And he had students that were doing some stuff that had done some stuff before at Frank Buck Zoo, but they're anyways. There's different stuff going on with animal behavior, and he was really open to solving this problem, to talk about this stuff. And when I went to sort of informally interview, they didn't have an interview process for grad students. They just apply and see if you get it. But I wanted to go see it, and he told me to go on a certain day, and I'm like, all right, sure, I'll be there. And that was a day that I think Ken Ramirez was giving maybe his first or second talk there. So I got to see that. I got to go out to dinner with all of them. I had no idea I was getting into all that. But it was really cool, really exciting. And that's where I ended up going and learning just everything about behavior analysis and becoming – here's where I gained another interest. Not just animals, not just animal behavior, but also – behavior analysis, but any behavior analysis. Because I was really focused on one problem beforehand, but being around a bunch of behaviorists helped me to appreciate just behavior analysis in general, how useful it could be. And then when I'm going for my PhD later, I actually was talking to a professor, Charles Abramson, at Oklahoma State University. That was someone I was talking to before I went to UNT. And Abramson did a lot of the invertebrate research. That's how I got into studying insects. And I couldn't totally appreciate it before I went to UNT, because I was like, I really want to work with bird social behaviors at zoos and reproduction and sort of behavioral conservation stuff. And this guy is kind of cool, but he's like sending me papers on like bees and worms and stuff. Like it's not the same. I don't want to do that. But like 3 years later, here I am, like emailing him again, and I'm like, actually, this is pretty cool stuff. I couldn't see it before. And then he's a lot like Jesus Rosales in the way that he's open about different problems. They're very different in some ways, in a lot of ways, but they're really similar, and they're open to a lot of different problems. So Abramson was like, yeah, just, bring your birds. We'll work on this problem. We'll work on the bee stuff. We'll build different things and do this and that. And Abramson's perspective is never say no to anything. So, I mean, this guy his publication record is insane. He's just doing so many things all the time. And by the way, you got to learn to say no sometimes. You have to do that. Like, you have to say no to projects sometimes. He disagrees with me, but it's fine. We can disagree. So he was just doing so much work, and we got to do the work I wanted to do. And he also introduced me to this invertebrate sort of research paradigm. And one of the really nice things about that, and I think he would agree with me on this, it's very practical. For some of the other research I'm doing, if I have like, it'd be hard to keep 30 pigeons in my house. I've had maybe half that amount in my house before, but 30 would be hard. And, you have to like have them and like raise them and then keep them. And then if you do one behavioral experiment, the behavior of the bird is now contaminated by your research. So you can't use that bird again. What are you going to do with 30 pigeons? And for sure, I didn't, get into this business to euthanize animals. It's not the thing I'm into. So Abramson's workflow was like, let's just have a beehive, and guess what? There's thousands of them. So, everybody can be doing different experiments at whatever time. And, when we need more bees, we'll just wait a little bit, and there'll be thousands more. There's a lot of reasons. I mean, there's a lot of reasons it's actually really challenging. And I can't remember if you were talking to this about me before we started the show, or in your introduction. It is cool to think, oh, cool. Opera conditioning works with every species everywhere. And I would say, okay, yeah, a little bit, but also it's different. There's some challenges there. And Abramson knew about the challenges, able to teach me about that stuff. But that efficient workflow, man, I mean, that's really useful. And that sort of got me in that direction. So now I'm like, okay, well, I like this stuff. I like herpetology. I like social behavior. I understand, the need for some efficient research species. Science, if you haven't heard the term publish or perish, it's a thing. And it means to be a professor, to be a scientist at a place that values research, you got to publish lots of stuff, or you're going to like either lose your job, or you're not going to be able to move forward in your job. And that means efficiency is really, really important. And sometimes it's about quantity instead of quality. And I'm not saying I agree with this stuff. I'm saying there's a truth to it. And the nice thing about doing some of the stuff with the insects, you can just have tons of them, man. Just tons and tons of them, super efficient. So I can keep that going while every once in a while coming back to another fun project, like with, the pigeons or rattlesnakes or whatever. So I guess that's how I started and where I got to. It's always been, looking back on it, it seems like I don't know how I would have gone through it any other way. I feel like I've just been sort of, I had my own early environment that directed me down this path, and of course I would have ended up here.
Yeah, well, and you contemplate how someone ended up researching with bees. It's maybe a little bit perplexing to think where someone would have to have been in, what experiences they would have had to kind of lead to that space. But hearing your story, you kind of like it all logically makes sense. They're all approximations, and you've seemingly kind of shifted focus numerous times, would you say?
Yeah, well, it's shifted focus, but it's also gaining appreciation. Um, and like I think Ryan, like your zoo background was at least originally with a lot of birds. Is that right? So
That is right. Yeah.
when I started working at the zoo, the first zoo I worked at, I happened to know the vet that was there because she was also a vet that I saw like locally for actually herpetology stuff. And I just decided, let me apply for a job at zoo. And there weren't, I don't know if there was like any particular jobs open or whatever, but they had you rank on there, what department you really wanted to work in. And I think I put, like reptiles and amphibians as the top, and then, maybe primates, and then blah, blah. And the last one, the very bottom one, was the bird department. Because I was like, I don't know, birds, man. Like, I like chicken behavior. That was fun. But I didn't have an appreciation for it until someone's like, well, this is what you got. This is your opportunity. And actually it ends up being a really cool opportunity. And I had like the best time of my life working at that zoo. And then, subsequent zoos after that, mostly working with birds, but, a lot of other stuff. I gained an appreciation for something that I couldn't have had before. And then it was the same thing coming to work with Abramson. And there's reason I don't like working with bees, which is why I'm moving away from that. But I never would have thought as like, an undergraduate student or a high school student, like my career is going to be working with bees. But sometimes you have an opportunity, and it's not just an opportunity for, your education or career. It's an opportunity to appreciate something new because we have like a lot of misconceptions about things. So yeah, I've changed directions a lot, but I think it's because I've had good opportunities to learn about more things. I still love everything that I've ever loved before. The difference is now I just love more things.
I'm glad you said all that because I'm listening to you talk about your mum bringing home chickens and then you teaching me literally in this podcast about all of the different vocalizations that you observed. How old were you at that time?
Maybe like early teen years. I think that happened before I actually went to college, and I just hadn't put it all together until a little later in college that I could also double major.
And do you have like vivid memories of that, of hanging out with those chickens?
Yeah. Oh yeah. Oh yeah, man. And I'm simplifying the story for you guys because like I don't have time to tell you about every animal that I grew up with. My mom, like when I was like an infant, she was an obedience dog trainer. Had to put that aside for a little while. When she retired from teaching, she's like a professional agility dog trainer, consultant, and now judge too. So we've actually got to bond over a lot of animal training stuff. That's really cool. So thanks for that, Mom, if you're listening. And we lived like sort of on a farm that didn't produce anything. So we had, like horses and sheep and goats and just we had dogs. I was always like finding, like toads and turtles and snakes and stuff. We had, we had some rescue animals too that we were working with a natural history museum. So they had a lot of animals that needed rehabbing and that sort of stuff. So I've always been around it. And the chickens were just one thing that my mom brought home. And, again, I had a misconception of like, I wouldn't be excited by them, but the language was complex. I don't even remember what you asked me anymore, but it wasn't just that. It was a lot of things. It was a lot of things. It wasn't one event like, here's a chicken. And then I'm like, I'm going to be a behaviorist now. It was a lot of little things. That's just one that really stands out as, sort of pushing me over the edge of a threshold, to shifting my perspective.
Hey, I told you that if you ask me at some point during the show, what was the question again? Then, hey, I've done my job and got you passion talking. But I was curious, like how your mind works as you walked us through your journey there, and kind of as you were seemingly putting the pieces of what's inevitably going to be your life story together to kind of get your direction and find where you wanted to go. And it fascinates me because I'm trying to as I hear people talk, I relate to personal experiences. I don't know if that's a common experience with everyone else. I think it might be, but like, I'm trying to think. You describe it as it's not changing focus. It's growing appreciation. And,
Yeah.
and you saw those as opportunities.
In retrospect, yeah.
I think I'm just trying to think. Like, is that? I don't know if we've had a guest who has expressed stuff like that. But when we talk about opportunities, we talk about opportunities like every failure is an opportunity to learn and grow. But that's not what you're talking about, is
Yeah.
it? You're
Well,
talking about like seizing what's in front of you.
yeah.
Have I
And
understood?
and yeah, and it's also about, and I might make this point later with comparative psychology. It's about you have your expectations. Everybody does. Everybody has assumptions. They're good to get you started. Assumptions are, that's like your behavior without any data. But when you get data, you got to change your assumptions. You got to shift a little bit. So, I had assumptions, and not all of them were right. So I shifted my behavior a little bit.
Has that been a motivator for you in working with some of the species that you've chosen to work with? Is to help others challenge their assumptions? Has that contributed to some of your
Um,
decisions?
I'm going to say yes, but no, because really, I mean, my interests are sort of selfishly driven of like, I think this is cool. I think this is interesting. Now, sometimes I also have to do things like saying, I think I can get funding for this. I think this is publishable. And sometimes I find a way of doing things like, hey, guys, this thing that I think is amazing is also important. Like, you should listen to this. This could help you. So that's where I'm saying the yes, but the no is like, no, I just think it's exciting. I don't know why. It's difficult sometimes. Working with unusual species is really hard. There's a reason why this is not the main thing that everybody does. There's a reason that for like research and behavior analysis, you've got pigeons and rats, and they're wonderful animals that are just so well suited for the kind of stuff we do with them. And there's a reason why you don't do stuff without, outside of those species. It's an additional challenge. So one of the fields that I'm really in is comparative psychology, which is about comparing similarities and differences across species. It's really about learning, like, okay, upper conditioning works, but does reinforcement in a cockroach, is that really the same as reinforcement in a dog? And the answer is yes and no. But, it's about comparing the different species. But even most comparative psychologists don't really do research with a whole bunch of different species. Most of them are going to find a few workflows that are efficient, and then they're going to talk to everybody else about that. It's hard to do a lot of different things that are just, drastically different. It's a setup cost. Each time you do something, it takes a lot of work, a lot of effort. And sometimes you do all that, you don't get anything out of it. Like we were joking about like a wasp sting earlier, and I sent you a picture I had of a wasp drinking sugar water from a syringe, because one year we're working with the bees, and one of my buddies, Chris Dingus, he got super into like, let's try not just working with bees, but similar organisms, because that's a comparative thing. I like to compare similar organisms. Let's try wasps. And at least in the United States, the region we're in, there's a lot of paper wasps that build nests, and they're really only there for a year. And so in the fall, when it starts getting cold, they sort of die off. The new queens go off to hibernate. Everybody else is just like stuck there with, no real hope for the future. It's just, they just sort of chill there until they pass. And so we went and we caught 900 wasps around the OSU campus. And we had a lab full of tons and tons and tons of wasps. And it was a lot of work. We learned a lot of things, and the research didn't go anywhere. So sometimes you pay the setup cost to do all that. You don't get a product out of it, but you still learn something. So it's still fun, even if you can't. And again, as a scientist, I have to look at the bottom line a little bit. I have to say, like, well, I got to get a certain amount of publications and progress and whatever, things that I can communicate officially to my field that I'm doing what I need to do. Sometimes you don't get that. The problems are hard to solve, but each problem that you attempt, even if you don't solve it, if it's a new problem you attempt, you're going to gain something, even if it's not a perfect solution.
Do you mean you have to gain something for the literature and to contribute, or do you mean you gain something for yourself and your own learning and development?
Yeah, I mean personally.
Yeah.
And I mean that just in a general sense. Anytime you're facing a new problem, at the very least, you're going to learn more about that new problem. May not be what you wanted, but it might be what you have.
So is that reinforcing for you?
Yeah, it shouldn't be, because I just so from a scientist perspective, here's the thing I should be doing. I should say, you know what? I figured out how to do this bee research. I inherited this sort of paradigm from my PhD advisor, and I'm going to do that with variations until the end of time. And I was seeing people when I was a graduate student that's what they did, and I was like, that's not fun. I want more than that. And I don't have a perfect connection for some of like sort of the applied animal training stuff, but imagine you're a dog trainer and you've decided, I'm really good with this breed of dog, and I'm really good with this breed of dog from this breeder, this line of dogs. I know what I'm working with there, and I'm really focused on efficiency. I'm really focused on just the goal. I'm just going to do this forever. But sometimes branching out to a different breeder, different breed, or even, so if you're like an agility trainer, you could, what is like another one, like fly ball? That's a thing, right? Even switching tasks, just switching that, you could learn stuff from that, and you might be able to improve your main workflow from that. But I think a lot of times it does pay to keep an eye on what's going to be the most efficient thing for me. Sometimes other stuff benefits you too. And then for me, like, I don't know, I just like it. Yeah. So yes, it is reinforcing for me.
So I was on your website, and I was looking at, I don't know, the resources I gave it in prep for this facilitated my understanding. I could have spent more time and dove a little bit deeper, but there is instructions on there to build a feeding device or a reinforcing device.
Yeah. So I told you there's challenges to solving new problems, right?
Yeah.
Okay. So one of the challenges is, so if I'm doing something like operant conditioning with rattlesnakes, so we did operant conditioning with rattlesnakes. To make it short, it's the snakes get warm, they press a lever that turns on the air conditioning. If you want to see it, you can do a YouTube search for operant conditioning in rattlesnakes. You'll find a video I uploaded showing like the overall thing. They learned it pretty well. One thing we learned, it's hard for an animal with no arms and legs to press a lever. Who would have thought? But when we went into this project, like we had some ideas we wanted to do. I was working with a herpetologist friend of mine that was also a previous student of my PhD advisor, Aaron Place. And Aaron was like, I want to do this stuff with the rattlesnakes. We had to shift directions a few times because the animals told us what was going to work, what was not going to work. And then we're like, okay, here's what we're going to do. You can't go online and find an operant chamber for rattlesnakes. It's not a thing. Somebody's got to build that. Somebody's got to design it. Somebody's got to wire the thing together. Somebody's got to write the program for it. And my undergraduate advisor, William Palya, like forever ago, he made a system that was about automating things like you would automate in an operant conditioning chamber. So if this lever is pressed 4 times, then deliver a reinforcer. And so you could also use it for, various training devices. We used it in the student laboratory where the students were training animals. He'd solved this problem like forever ago. And then I sort of went down the same path, solving that problem with newer technology. And so that's one of the things. We used it for rattlesnakes, bees, horses. We used it for the horse project. One of the other grad students used it for a project with infants. I met a guy at a behavior analysis conference that we set up something in his backyard for squirrels. And so there's a need for that kind of stuff, and you just can't buy it. And so as I was doing it because I had to. Also, you might imagine I started to really enjoy doing it. Like I started to like it, and now I do tons of programming stuff now. It's like a hobby. It's a problem, but that's whatever. My perspective was like I'm doing this because I love what I do, and because I love science and I love learning and I love behavior. So anything I can just put online for free, I'll just put it online for free. I'm not in this to make a business out of it. Also, running a business would take time out of doing the parts of it I love to do. So yeah, if you go to my website, and I apologize for anybody that's been there recently and it's a little bit outdated. I'm sorry, I'll work on it. I do have some articles on like a syringe pump that I built for a project that didn't actually go anywhere, but I just went ahead and wrote up the whole syringe pump thing, and I'll have people contacting me from like robotics departments for that sort of stuff. A chemistry department student one time contacted me about how to put this thing together. Anytime you need to deliver fluid, okay, people use it, but it was designed to deliver things like sugar water or condensed milk or like a dog food paste or something like that. There's some all my software is there, and that was my dissertation. Actually, it wasn't behavior analysis, it wasn't comparative psychology. It was my software to do that kind of stuff. I've had different people use that. Sometimes I get contacted about that, and there's some general links of where to find stuff, where to buy stuff. I would like to clean all of it up, but I just try to put as much stuff online as I can that maybe it'll help somebody. And that's something I can do.
I get it probably on a I haven't built a automated sugar feeding device before, but I did spend 2 hours this morning trying to get our computer synced up with our network on our new Google Wi-Fi. Completely failed. And so I was like, oh my God, I didn't have 2 hours free to do that. So I understand I'm motivated to automate and use technology to improve systems as well. But let me understand this. You can go to your website and you can get all of the information, including links to the robotic, is it robotic? Like the parts online store where you can buy the individual parts?
Yeah, an operant chamber is like an inverted robot. You have all the stuff on the inside, and just like an animal interacts with it. It's really similar. When I was learning this stuff, and I got some help from my undergraduate advisor, I got some help from my PhD advisor, but I'm having to go learn a lot myself. And yeah, I'm learning tons of stuff from robotics tutorials. It's really, really, really similar. I forget all of what I have on there, but I know I do have the software. The first publication we did with it, and this was my PhD advisor's idea, make the software and then make a series of programs for every single sort of basic procedure in behavior analysis you can imagine. So that if someone wants to use it for a classroom to teach people, and say here, students, let's do this experiment on classical conditioning. There's the program. Let's do this lesson on schedules of reinforcement. There's the program. And to be honest, it's something I'm intending to do for some of my classrooms. At Converse College, we have a small rat lab where the students can get rats, put them in operant chambers, and then press play. They go to class, they get the data, they come back. But they're not able to see the rat doing the stuff. So I'm intending to have one I can wheel into the classroom and we can do different stuff. So that's on there. I know I've got links to general vendors for things. I might have a few feeder tutorials. That's a common sort of need. Just look at there's stuff on there. Look around. I'll try to keep adding stuff and just more things. But yeah, it's designed to be I can't do everything for you. I regret that. I actually might have said yes to too many projects before, and I still got some I need to catch up on. I regret that I cannot do it as a business. I cannot do this stuff for you, but I'm super happy to help anybody get started learning about this whole new area, because that's the hardest part is it's not true for everything, but for some behaviors, the first step is the hardest one. And once you're able to get that, you're able to sort of teach yourself more and more and more and more. I mean, imagine if you're learning about operant conditioning. You can get way better at it than when you first learn. But first, you got to learn what reinforcement is. That's got to be the biggest hurdle, just the overall concept. And then little improvements from there that you maybe can handle yourself.
Well, I found when I was Facebook stalking you before this podcast, I found, thing I read to you before we push record. I'll have to go back and look at it. It says, first you've got to suck at something to become, to approximate towards being decently... Oh, I'm completely butchering it. Are you finding it?
Yeah, I'm trying to find the quote.
Awesome. It was so good. Like, I want to share it in our membership community. So to edit the actual proper unbutchered quote to this podcast would have value.
So this is a quote from Jake the dog in Adventure Time. If you've not watched Adventure Time, I highly recommend it. It's a really good show. There's moments like I like cartoons that can also make you cry. And Adventure Time, if you've seen it, there's some moments. The quote, I don't know what the context is. Sometimes there's no context for anything in the show. The quote is, "Sucking at something is the first step toward being kind of good at something." Which, yeah, that's life. That's shaping. That's learning. That's how you go about it. Don't be discouraged at that first step.
So, like, do you get excited when you suck at something?
Because that's such a weird question. You get excited when you're like just objectively terrible.
Like, but I was reading that comment earlier today, and that's the thought that came to my head. Like, because the thing that will make you not try it is fear of sucking at it, right? Potentially, depending on the individual. Yeah. So, to reframe that, you might say, "I'm about to suck at something that is so cool."
Yeah, maybe. I think my perspective's a little different. I'm not worried about being bad at something at first, because I feel like most things, if you work at it, and sometimes you need some guidance. Like sometimes there's parts where you need, somebody to help you observe your own behavior. Guide your shaping steps a little bit. But if it can be done, like, shouldn't you be able to do it? I mean, like, objectively. And growing up, one more shout out to my mom. Hi, Mom. We had all sorts of animals, and we had to, like each animal can break a fence in a different way. So, like, the horses, like, lean into it to get grass on the other side, and they'll break one type of fence. Goats will, like, rub their side on it to scratch themselves. They'll break another type of fence. Sheep will, like, go under electric fence and their wool will get caught on it. They'll break a third type of fence. So every summer, and I hated doing this, every summer we have to, like, re-fence the entire property. I hated it so much. There were always things breaking, always things we had to build. But what I was learning, and I got a lot of this from the first zoo I worked at too. Anybody from Southeast United States, check out Birmingham Zoo. Is you just have to sometimes just figure it out. You just have to. You just have to do it. And like at Birmingham Zoo, we moved a barn one time by hand because they were going to, like, destroy this one area to build a new thing. And we had a storage shed there that we just put sticks under and, like, moved by hand. I worked with some really great people there that, along with my mom, helped teach me that just try. It's not working. Take a minute, figure it out, try something else. You will have moments where you're like, I'm feeling like I'm getting that emotional extinction burst coming. I really want this to work, and it didn't work. And I guess, repeated. See, now I'm like thinking from like an experimental behaviors, thing. Can you train out the extinction burst with like repeated extinction exposures so that an animal's like, is really robust to experiencing some extinction and then just be like, nah, it's fine. I'll keep doing it anyway. I'm not going to be emotional about it.
It's like, well, I'm just thinking about my own experience, and then potentially non-human learners and other human learners experience similar things. But like when you go through a bunch of extinction bursts, but you, on whatever behavior you might be training or project you're working on, you inevitably reach your end goal. Like one reflection I've had is, were all of those extinction bursts, those avenues I tried, necessary for this current success? Like, I don't think I could be here unless I did all of those things. Yeah. Therefore, that some recent experiences in that made me go, like, awesome that didn't work. Now I'm closer to finding what does
Yeah,
work.
you have one bad strategy totally extinguished. Now you can move on to the next bad strategy, and one of them eventually will be the thing that gets you there. Yeah,
Yes,
okay, that's a cool way of thinking about it.
I think another herpetological episode we've done is with Carrie Kish from Reptelligence, and she used to say "fail forward," and I've taken that on board, and I say it quite a lot. I'm like, all right,
Yeah,
let's go, team, fail forward. Let's go fail.
Yeah, that's just failures. I mean, it's still selection of your repertoire. Just yeah.
Hey, we talked about some of your research, the stuff with rattlesnakes. I mean, I'm keen to unpack that more, and you mentioned some of the work you've done with horses. But can you just, because you've got like we mentioned in your bio, and as you've alluded to already via the offerings you've shared with us, diversity of species that you've worked with. Can you walk us through some of the other research you've done, and touch again on some of the research you've already mentioned? Start from the start.
Start from the start? Is that what you want?
You can pick and choose.
Okay. Well, I've got so the rattlesnake stuff. You guys check it out. Check it out on YouTube. I think it's pretty self-explanatory. I am dying to get back into more reptile amphibian research. Toads are my favorite thing on the planet, but I haven't got to do a whole lot of that. So I can tell you about two other main venues, which will take from now till the end of time. But I'll start, and you can stop me. The project I got really into from working with zoos, I think this is an important one to talk about, is at zoos, a lot of times you have some species of population concern, maybe not necessarily endangered, but sometimes endangered, protected. And sometimes you have collaboration to get two individuals together from different zoos that are like supposed to be genetically compatible. And there's a lot of conservation efforts here, a lot. That's really common. But sometimes working with the animals and their behavior, it sort of gets in the way. So at least with birds, a really common thing that'll happen is you will be trying to breed birds, and something happens along the way, and now you are responsible for hand-raising this bird. Whether it's like the parents didn't sit on the eggs, so you have to incubate it and raise the chicks. Or maybe a wild animal got into the cage and killed the parents, and now you have to raise the babies. Maybe the parents started fighting. There's a million reasons why it happens. It's really common. So you have to hand raise these birds. Some of you will know where I'm going with this, but when you're raising a bird inside a building, that's what's going to be normal to this little bird. And if you want to go look in the literature, you can look at the research on imprinting. So that's sort of the jargon term for, well, the birds imprint to the first thing they see, and they're going to treat that like a parent. It's usually talked about for precocial birds, so things that hatch out of the egg and can run around like chickens, ducks, quails, turkey. But the literature sort of biases that, but it happens pretty much everywhere. And if you want a human approximation, you can look up attachment. That's sometimes applied to mammals. I'm telling you a bird story, but this is a really sort of a broadly applicable story. Just the terminology might change. So these little birds that you're raising, they're going to imprint to you. They're going to sort of interact with you. They're going to beg for food from you, and it's adorable. I love it. It's great. But then when they get older, they have a social repertoire that sort of is going to come out to whatever thing they've bonded with, whatever thing they interact with, and that's going to be people. And so what things do adult birds do with other birds? Well, they mate with other birds, and so you will have hand-raised birds try to mate with people, which is like funny at first, and then it's kind of like, dude, that's weird. And you will also have sometimes birds see you as their rival. I've known plenty of birds that are hand-raised that can be insanely aggressive, like more aggressive than you would ever encounter in a wild bird that was terrified of you. Because they see it as an even playing field. And they're like, you're coming to steal my girlfriend. And I'm like, no, I'm bringing both of you food. And they're like, you can't get near her. And they will come after you. Personally, I like working with like big storks and cranes that can get kind of angry and kind of scary. I like a bird that can fight back a little bit. It's kind of fun. But I mean, they can do some damage. So when you're trying to get some of these hand-raised birds to breed because, like, I have this individual that's of an endangered species. I want it to breed, and you put it in with another bird, and it's like, I just don't like birds. It's not my thing. I don't swing that way. Or it can be afraid of the other bird, or it can like them and just not have a good social repertoire at all. It's a big concern. And the main thing you do is you raise the birds with this in mind. So with captive breeding programs, you will raise the bird with, you're wearing like a puppet of the parent bird on your hand. So that's what it sees, something that looks like a bird. You will raise the birds. Like I was raising a dove one time, and I really messed up with this dove because I got him to be an adult, and I take him outside, and the poor guy's terrified of trees. And I'm like, I forgot. You never saw trees when you were growing up. This is scary now. That's the thing you're supposed to be in. So you got to really sort of plan in advance for all this stuff. Captive breeding programs do an excellent job of that. But I wanted to know, when they get there, can you fix it? Can you teach an appropriate social repertoire? And the imprinting literature, I think it's really exciting. I love reading about it. It sort of peaked in the 80s. And by the way, science moves in fads too. Scientists are social human beings. There's fads in science. So literature sort of peaked in the 80s. I think a lot of things weren't resolved, but I don't think it's anywhere near as fixed as the literature says. I think you can change things. I've done that before. So one of the projects I did, first at UNT, and then later at OSU, and this was the project that I was like, yeah, I'm an undergraduate student ready to save the world, and it has to be this problem or else. So that was my thing I was a little too focused on. What I ended up doing is I ended up raising pigeons. There's a lot of reasons that pigeons worked out, better than some other animals would. Baby pigeons, if you haven't seen them, they're ugly and they're adorable at the same time. Pigeons are it's another animal that has a lot of misconceptions. They're actually really good little birds. In my experience, pigeons and doves, as just sort of in general, are very chill birds. So really great to work with. There are reasons they're lab animals for behaviorists. So I hand raised a bunch of these guys, and I raised them to where they only got to see me. And then I also had some wild pigeons that I would catch, or some that I bought that were parent raised. So I had half of these birds were human raised, half of these birds were parent raised. And I was using a procedure. I'm not sure who first did it, but popularized by Michael Dumian from University of something, Texas. I forget where. It's called sexual conditioning. And this procedure, you have male bird and a female bird. They know each other, or they like each other, or it's a species that just doesn't discriminate, and they'll get together with whatever. And you just have your male in a box, and then a light comes on for 30 seconds, and then a female appears. It's classical conditioning. At first, the light is meaningless, but after a few times, the light starts to mean, hey, ladies are coming. I'm getting really excited about this. And what's really cool is you'll not only get the birds approaching the light, they'll peck at the light, they'll call to the light, they'll start doing courtship behaviors, but you'll start getting biological changes in males and females. You will get increased fertility, which is really cool. And I don't think it's just behavioral. I think it's like the conditioning affects them at a biological level. So I was going to try that procedure. And I had, for the parent-raised birds, so these are pigeons that they've grown up with pigeons. They're sort of, regular pigeons. They tolerate people to an extent. Some are friendly, but they like to socialize with other birds. I would have them in an apparatus. I would have a light come on for 30 seconds, and then a little sliding door would open, and then out would pop, their mate, the pigeon that they lived with, that they were bonded with. And they get to hang out for a little bit. And I would just repeat that procedure over and over and over again, as you do for, conditioning. Repetition is important. And pretty soon, when the light comes on, they're going over to it, they're pecking it, they're cooing it, they're running around in circles, which is sort of a pigeon social thing. And that was sort of my control there to make sure, okay, this procedure works with pigeons, right? No reason it shouldn't. Okay, fine. The thing I really wanted to do was, can I take my hand-raised pigeons? They've never seen another pigeon. They love people. Can I teach them to associate another pigeon with access to a person? They have social behaviors they direct towards people, which sometimes means they love you, sometimes means they want to beat you up. But it's all social behavior. So I had a little system where I would open a sliding door. My subject pigeon, my hand-raised pigeon, would see another pigeon for 30 seconds. I would close that sliding door and then open it again, and then there was my hand. And they could come over to my hand, and they would be pecking at my hand, preening at my hand, or just cuddling up next to it. And so that was their, like the other pigeon was a CS, my hand was a US. You do that over and over and over again. And it works about half the time. Maybe I have to go back and look at the data. Maybe a third of the time is a little more fair. You will get a hand-raised pigeon that is imprinted to people that, at least according to the literature, should never be able to get past that, never really be able to interact with other pigeons. And I stress according to the literature because things that animal trainers know, things that, people that work with animals at the zoo and at the farm know, it's not always in the literature. It's not always there. But according to the literature, they should not be able to get past that. And I had like a third to half of the birds would be able to get past that. So I was really happy about that. It's a rather challenging project because you have to have a lot of animals. And I had, I think, at 14 at most at one time. You have to hand raise them, which is very taxing. And then once you use them, you have to find homes for them. That's takes time too. So it's something I haven't been able to. I really like to go back and do it again. I like to do more of it because I think it's a very important thing. But when I do it again, I'm not going to do that procedure because the biggest issue is that even though you're saying, let me just teach an animal, CS means US. If your CS is not neutral, you will have some trouble. The hand-raised pigeons were afraid of other birds. It wasn't neutral to them. It caused fear. So I would present a pigeon for 30 seconds. My subject pigeons would run away and they'd be standing real still, suck their feathers in, freaking out. And then I try to show them my hand and they're like, no, I'm still kind of scared right now. I'd rather chill over here in the corner. Some of them would get past it, some of them wouldn't. The way I would go about it again is the first thing you have to do is remove fear. And so this is another sort of take-home message for this particular research experiment. That's really important anytime you do training. Fear, if anybody, I'm sorry for this quote, but if anybody's a fan of Dune, fear is the mind killer. Like, it will prevent anything else from happening. So you have to address that first. Habituation is one way to do it. Ryan, I don't remember if you've had anybody on here talk about constructive aggression treatments.
Yeah, we have within our membership. We've had Jesus talk about it.
Okay, he talked about it. Okay,
and Sean's talked about it. But
yeah, I know Sean mentioned it a little bit because his thing is sort of related to that in a different direction. That procedure works really well, and I've actually been able to catch a wild pigeon, do that procedure, and then it's as friendly with me as any other hand-raised pigeon. So I would, if I did it again, I would really focus on that. I really want to see a ton more research on that. But yeah, fear is massive. Fear is super important. That's one lesson from this thing. And the other lesson is, again, I'm telling you a bird story, but this is any animal that has parental care. I think this is going to happen. The early environment really affects later behavior. And I mean, a lot of animal trainers know it because you're like, well, and I don't know the weeks for this, but you're like, okay, I'm hitting the second puppy fear period. I got to take my dog around a bunch of things now because I want it to be exposed to these things when it's young so that it doesn't freak out about it when it's old. There'll be different names for it for different communities and different species. But I think that's something really core, really fundamental. The reason I haven't gotten back to it is because it's hard. And I told you I have to at some point. I need a certain number of publications. I need funding. And because I use that stuff to pay my students too. Like they need that. And there's some projects that are a little harder, a little longer term that I just have to do, every now and then. Like with the bugs, like we could do like 2 or 3 publishable experiments a summer if things go well. With something like this pigeon experiment, I have to raise them, which takes forever. And then I have to wait for them to become adults, which also takes forever. And then I've got to do the experiment. So I can't do as much of that as I would like. If anybody wants to steal that research from me, go ahead. Just go do it. I would really love to see it done. I think there's a lot of really important things to be done there, especially if you take a broad perspective of this is not just a zoo bird problem. This is a broad problem. This is of importance to a lot of people.
Yes, I know there's going to be a lot of people listening to this who are going to be taking a lot away from that and especially your lesson about the fear. I know that's kind of a topic that a lot of people are learning about now, are getting ready
Yeah.
to suck at for a while.
Yeah. And think about your own anxiety. You can be paralyzed with anxiety. It's very similar, works, in a lot of the same ways. You got to deal with that first sometimes. Sometimes you want to say, yeah, just suck it up, power through, but sometimes it's a lot and you really need to address that first.
Absolutely. And I think you mentioned, I said start from the start and pick and choose. And I think you mentioned there's 2 areas you wanted to talk about.
Yeah, I got one more broad area.
I think that'll be a good fill for this episode. We're going to turn this into a 2-part episode, everyone. We're getting good at that here at Animal Training Academy. I guess, give us another 5 years, we'll be doing 3-part episodes of everyone because there's just so much to talk about. But tell us the second area that you decided.
Okay. So I'm laughing a little bit because I am a professor, so I do prepare my lectures. I prepare stories. I have things that are. This is not totally spontaneous because that's my nature. The other story I wanted to tell all of you was about working with a non-traditional species, because that's something that's totally different and it's really uncommon. And I've mentioned it's really hard. You've got me talking about some of the stuff already. So the bees that I was working with, we were working with honeybees. I think they're pretty much global now. Like they've been brought everywhere by people. They're really, a big part of our agriculture and ecology, whether, that's natural or not. So we did a lot of work with honeybees. There's actually a huge section of research that does research with honeybees. There's some other invertebrates that are used a lot, like fruit flies, planaria, some roundworms. So there's those things, but the bees were one that they're maybe a little more behaviorally sophisticated than like a fruit fly. And I'm not knocking any of you guys that are listeners that your thing is fruit flies. It's fine. It's fine. It's not my thing. So honeybees, they live in a hive. They go out. They find nectar. They find pollen. They co-evolved with pollinating plants. They're really specialized to do that. They bring it back. They build little honeycombs in there out of wax, which comes from their body. And then they fill it with pollen and nectar. It's pretty involved. And the research that's really interesting. And you can see things like they can learn super fast. Like one trial learning is not hard to get. You can get really good, really fast learning. You can get them to learn some abstract concepts like similarity and difference. I'm a little skeptical of some of that work, just because I know some of the trade pros and cons of bees. I've seen some stuff on observational learning in bumblebees. A little skeptical of that too, because I know some of the pros and cons of working with bumblebees. There's some stuff on mood and emotions. We've done research on learned helplessness. There's so much stuff. It's impressive. But the thing is, the bees are super, super specialized. Yes, they will learn from class conditioning. They will learn from reinforcement. But it is not a dog. It is not a pigeon. It is not a rat. It is not a person. It's a bee is a bee. It's a totally different thing. And the goal of comparative psychology is, hey, let's study similarities and differences across different species. And because you're focusing a lot on different species, and because early on comparative psychology was really a US thing when behaviorism was really big, it's a lot like early comparative psychology is a lot of upper conditioning, class conditioning, a lot of those, classic behavioral procedures. So that's the goal. Let's compare that across species. And it doesn't always work out like you think. I've never worked with a species where I'm like, this species cannot learn through positive reinforcement. But I've worked with a lot of species where I'm like, this is a little different. This is not the same. I'll call it reinforcement. I'm happy with that. But so something's a little different here. And that's the goal, is get to figure those things out and then figure out why they're like that. The bee issue is they're super specialized. And you really have to understand that really, really well. Anytime you're going to a different species or even a different problem, you need to know what the species is. You need to know what the problem is. You will have knowledge that will generalize. You'll have quite a good deal of that. But you cannot be blind to the areas where you are wrong, because then you'll say, oh, well, the bee is like a dog. Why is dog training the bee not working? Because it wasn't a dog. It was never a dog. So the big thing with bees, it's a colonial species. You have the queen, she does the reproduction, and then you have worker bees. The worker bees are the ones that are out there flying around that you see. You'll rarely ever see the queen. I don't think I've ever seen one in the wild. I've seen swarms of bees where I know there's a queen in the middle, but I've never actually seen a wild queen. So you see the worker bees all the time. The worker bees have pretty much no evolutionary fitness. They don't reproduce. They have no genes to be carried on. Now, there's some really cool research that entomologists and evolutionary biologists do on how that sort of system works, and it does work for certain reasons. But just consider for a moment that, like, the bee's behavior might have evolved for a different reason than your behavior. We're social organisms. We interact. We would not survive. I mean, like, humans are good at, like, stamina running, good at throwing things, good at talking, good at tool use, but we're not that fast. We're not that strong. We've got terrible defenses. We would not survive without social communities. But our behavior evolved so we can take care of ourselves. And we can take care of ourselves if we really need to. Bees are not like that. The worker bee evolved to bring food to the queen, to take care of the queen, to build things for the queen. The worker bee is kind of an extension of the queen. That's really the best way to think about it. It's not its own organism. And that's why you'll see certain life stages of certain bees will do things like starve to death with food right in front of them, because they don't have the ability to feed themselves at that particular part of their life. So they're just super specialized. We have a lot of results with them that were a little surprising, that I think is because of that specialization. And when I came to Converse College, where I am now, I needed to start my own lab. And I didn't want to have honeybees because, one, they're really specialized, and there's a lot of little finicky things there. And two, you got to keep them inside. So you can't keep them inside. You have to have a field for them. When you have a field for them, we're dealing with things like, the weather. If the weather's bad, we can't do the research. Parasites, pesticides, herbicides. We don't give them that stuff, but they'll go find it and bring it back. We'll have things like we were going to do an experiment one summer, and we go to get the bees, and they were gone. All however many thousands of them swarmed, flew away. They're like, see ya. So we had to get more bees. We've had hives become Africanized. The killer bees, I think, are not quite as bad as people think, but you still don't want that, right? It's not what you're looking for. So when it's an uncontrolled environment, it kind of, messes with my obsessive need as a scientist to control everything. So when I came to Converse, I didn't have a field. I didn't want a field. I was kind of tired of getting stung in the face, and I wanted something more controlled. So I started looking towards bumblebees. Bumblebees, objectively, I think they're the cutest insect I've worked with. But you can get them from companies. And I don't know about where you are, Ryan, but at least in the United States and Europe, you can buy them from companies that use them for greenhouse pollination. And they captively breed whatever the native species is. So where I am, it's Bombus impatiens. Bombus terrestris in Europe is really common. And they do that because you can put a bumblebee hive in a greenhouse and they'll pollinate stuff just fine. Honeybees will fly out and they'll be like, what is the meaning of walls? And they can't. They'll fly into the wall. They won't be able to find their way home, and the colony will just fail. Bumblebees, a little better. So they're sold for that purpose. And the last like 15 or so years, a lot of researchers have been like, let's do bumblebees. I don't want to have an outside hive anymore. Let's get bumblebees inside. So that's what I did when I came to Converse College. And there's a lot of really cool research with bumblebees now. One of my reviewers sort of slammed me for saying it's a newer thing. It's relatively newer. It's been a while. Honeybee stuff has been around really popular since the 80s. Bumblebee stuff is relatively newer. So don't jump down my throat if you're an expert on the history of bees. So I had bumblebee hives, and they come in a little cardboard box with like a plastic beehive in it. So it's like a foot cubed box, or like, what is that, like 30 centimeters cubed. And I connected that to a big screen cage that was actually a modified, I guess a modified chameleon cage was what I had, where they could fly in there and they could go get their nectar and go get their pollen, and they could fly back home and give it to the queen, and they could grow and thrive and whatever. And the biggest issue was, you're supposed to be able to do this research, right? I've read all the papers, I've done all the stuff. The bees would fly out into the hive, land at the food bowl, and they would be like, you know what? Let's stay here. This is great. Let's just live by the food bowl. So the worker bees were there. Meanwhile, the queen's in the hive getting hungry. She doesn't have any more food. She needs them to bring the food back. And in bumblebees, the first set of workers are not really as good at foraging, and the queen will help them out sometimes. The second set of foragers, it's a gene expression development thing. They grow bigger and stronger, and they're better at foraging. They're better at going out there and getting stuff. We couldn't get that new type of worker bee because the first worker bees are like, let's all just live here near the food bowl. And I mean all of them. Like, we grafted one time. I think we had something like 300 bees in a hive, and it took a month for half of the bees to decide, let's live by the food bowl. And so my students and I, we were trying to do some basic associative conditioning. So maybe I'll find a video for you guys later, but if you do a YouTube search for like opera conditioning in bees or classical conditioning in bees, or especially proboscis extension response conditioning, PER conditioning. There's a ton of stuff like on that on bees. And you take the bee, you restrain it, it's hungry, you blow some odor across its antenna, and then you give it some food, and they'll super, super quickly learn odor means food. This is where you get really good one-trial learning. I mean, really just amazing acquisition curves. They can be very, very smart. But the issue we had was the bees they weren't like my poor students, like working with hundreds and hundreds and hundreds and hundreds and hundreds of these bees. Probably at least 400 bees that we went through. I don't have the total number, but around there. And we could get learning. Sometimes we could never get anything reliable because the issue was the bees that became isolated from the colony that we're collecting while they're getting food, which is the way you're supposed to do it. They're not designed to do that kind of learning. We needed the next batch of bees that could never be produced because even though bumblebees can live inside, they don't thrive. It just doesn't work quite right. So it's a thing that, and I'll say this again about literature, the scientific literature doesn't always have all the things in it that it's supposed to have in it. This is a thing that I found twice in the scientific literature, sort of very informally mentioned. And me, since reviewing papers, I've asked authors to include this stuff every time in it. But in contacting different researchers, every single one of them has this problem. Whether it's the North American species or the European species, it's super, super, super common. And there's lots of little Band-Aid solutions, which include like catching them, putting them back in the hive, killing the ones that get out over and over again. My favorite solution is just don't ever let them out. Like, you don't let them out of the hive, they're not going to get lost coming back. The way we solve this problem, and here's like lesson one from this story. Class, take notes on this part. I was looking at, so we'd gone through several years of this, and I was looking at a spare hive one day, one of these spare little plastic boxes that they come in. It's very specifically designed for whatever the manufacturer needs it to do to make the bees work. And there's a bunch of ventilation holes in this little plastic box because, like bees need air and it helps regulate temperature. And there's like one main entrance and exit they can go in and out of. And then I'm looking at it, and there's like a bunch of little ventilation holes like right near the entrance. I'm like, that's interesting. And I look at it a little more, and the ventilation holes start at the bottom of the cage, and they go all the way up to that little exit entrance hole. And it's not a ventilation hole. It's a ladder. It's a ladder. And I started thinking about, why would the manufacturer have the behavior of putting a ladder in this spot? And the reason has got to be reinforcement. If you put the ladder in that spot, the bees get out okay. If you don't put the ladder in that spot, I bet the bees wouldn't get out. Like there's a reason they did. I mean, they're like all about saving money. They're not going to put a ladder in there for no reason. And when I started thinking about it that way, I started looking at my overall setup for them, and I just let go of thinking about them as an organism with a goal, with with goal directed behavior. I had to stop thinking about them as like the bee wants to get food and wants to come back but is not able. And I started thinking about, okay, just hypothetically, what if they're just like particles bouncing around randomly that don't really know where they're going, don't really know what they're doing, but in the wild it's good enough to work. Evolution produces things that is good enough. Our own reinforcement contingencies also produce things that are good enough. All animals are lazy. All animals procrastinate. Good enough is a really common theme. I'm sure your listeners, there's something you did recently that you could have done it better. You could have done it sooner, but you did good enough. It worked. For sure. This is something I know about my students as well. I know. So I stopped thinking about the bees as having any sort of goal or intent to them. And I was like, what if it's just like a particle that just bounces around randomly? And I was thinking about what if it's like water? Water can get drawn up by like a paper wick. It's not like the water wants to go up the paper. It's just a property of what the water is. There's no goal, no intention. But if you have water and you have a little paper wick, it's going to get drawn up in there. And I'm thinking, okay, what if the bees are like little water particles bouncing around? That ladder's like a little wick that draws them out, and they keep bouncing around until they're out of the hive into this main cage. But now there's nothing to draw them back in. They don't have the intent of like, okay, now that I'm out, I'll get food and come back. They need something to make it happen. The solution that I had, and this actually worked really well until one day I left the thing open and all the bees got out overnight. It's a long story. We'll save that one for another time. The solution that worked really well is I had one hive that I ordered the bees. They came in, and I had one hive from a bee colony from the previous year. The bumblebee colonies only last a year, so I had some surplus hives laying around, and I just connected them together. So I had two physical spaces with the same dimensions, same properties to guide this animal out into this feeding area, and that feeding area had the same properties to guide the bees back in. I just equalized the probability of stumbling out and stumbling in without any sort of purpose or goal. And once I did that, everything just worked perfectly. So until I let the bees out. There's the song "Who Let the Dogs Out," and my lab was like, "Who Let the Bees Out?" It was me. I didn't mean to. I'm sorry, that's a bad joke. You can cut that one. But you had a thing.
No, I'm saying that's standard.
Yeah. So this is the other thing I do in class. I distract myself. Anyway, okay. So what I had to do, and this is one lesson. Is I just had to stop. I had to stop assuming that. I already told you they're not pigeons. They're not dogs. They're not ducks. They're not people. They're not whatever thing that you work with. They're bees, and I even had to stop assuming that they had the same kind of like goals that I would assume. And I just had to let go of all my assumptions. It's a lot of assumptions. We carry around so many assumptions about so many things. Generalizations are there to help us out in the absence of information, but you got to change it. You got to be willing to change it. And I had to let go of a lot of assumptions, but that's when things started working. And that is a major thing you have to do every time in comparative psychology is say, like, I want to go study, upper conditioning in rattlesnakes or, in turtles or, frogs or whatever, weird stuff I'm doing. You have some knowledge you come with, but it's a lot of adjusting that. And I think it's really hard to let go of some of our assumptions because each species has its own behavior. That includes us. That includes human beings being how we are. Human beings Any developmental psychologists out there, correct me if I'm wrong about any of this stuff. I don't know the specific ages and everything, but human beings are really bad at things like empathy, perspective, understanding things when we're really young. So like a kid that has a favorite toy will be very upset if he breaks his favorite toy. But if a kid breaks his friend's favorite toy, it's like, I don't know why my friend's upset. The toy wasn't that good. I don't care. When we get a little older, and I think it's around like 7 to 10 or so. Again, somebody, correct me. Send me angry emails, whatever. We get past that by starting to assume other people feel and behave like we do. It's called theory of mind. So a kid can be like, well, I broke this fire truck, and I think the fire truck is the most terrible toy on the planet. But my friends spent a lot of time playing with that fire truck. I think they liked it. And if I broke a toy that I liked, I would be really, really upset. Therefore, my friends should be upset. And this theory of mind, it's how we start to understand other people. And it works really well until it doesn't. And where it doesn't is when if you're interacting with people that maybe from different cultures, maybe have had different experiences. I've had plenty of friends that are like on the spectrum a little bit, that just things are a little different for them. You can't assume they're like you. You need to learn how they are. And really, I don't want to like focus on mental health as the only time you have to do that, because it's always that. And when you're working with your animals too, you got to let go of some of that. And we assume the animal's going to do what it does because it has a goal, because it understands, because it loves me. Maybe those things are true. Maybe, but maybe not. And I think that is the hardest thing to let go of as a scientist, as a behaviorist, as a comparative psychologist, as an animal trainer. You got to let go of a lot of those assumptions. And even just as a human being interacting with, friends, families, loved ones, coworkers, whatever, is letting go of your own assumptions, because you get a lot invested in them sometimes. And so with the bees, I had to let go of assumptions. Things worked a lot better. We still moved on from bees because the way they are is not the way I wanted to go about it. And then I started moving to cockroaches, which are objectively, they're not as cute as bees. They're not as cute. By the way, there's something like over 4,000 species of cockroaches. Only about like 5 or 6 of them are pests. The trick is, don't work with those 5 or 6. Don't have those. Do a Google image search for like beautiful cockroach or like pretty cockroach. You'll see they come in all sorts of colors and sizes. They have all sorts of sort of life history strategies. They're social. They talk to each other. There's a lot of really cool parental care strategies. There's roaches that feed their babies roach milk. There's a lot of crazy stuff. And the roaches ended up working a lot better for me because they are very efficient little bugs to have. I mean, I just toss an apple in there a week and I'm done. Like, I don't have to do anything. Bees, you have no idea how much time we spent taking care of the bees, and they were very creative in finding ways to kill themselves. Like, we came in one day and there were a bunch of little dead white bees everywhere in the cage. And I'm like, what happened? Is like a fungus growing on or something like that? No, they went to their sugar water bowl, which is one type of food they have to have. They fanned all the water out of that, added some enzymes to make it into honey, ended up turning it into glaze, and glazed themselves to death. So roaches, you don't have that problem. They know how to take care of themselves. They're actually really, really good animals to work with. I don't have any major life lessons about that. But they've been working out really, really well for us. And actually, they're pretty smart too. So far, they're keeping up with the bees and everything they can do. But they're generalists. They're not specialized. They're hardy. Just really, really efficient. But you do have to, with whatever stuff you do, you got to figure out what the animal is. And I picked the species of roach that I picked because I did tons. There's a roach keeping hobby in the United States, and I guess in Europe a little bit too. And I made a spreadsheet of every species you could get and all the pros and cons. And I picked the one that was the easiest to work with, but also had the most crazy appetite. The species I work with is called the orange head cockroach. Their appetite is greater than any species I've ever worked with. And I mean, it's probably hundreds that I've worked with across, farms and research and zoos and everything. They're hungry enough, they will also predate on smaller insects. Closest relative to cockroaches are termites, which are cockroaches actually, and praying mantises. When these guys go after cricket or something, you can see that. There's a few other labs in the United States that started working with hissing cockroaches to teach people about behavior analysis, believe it or not, because rat labs are expensive. Again, that invertebrate practicality theme is very important. And I think they've done some really cool stuff, and they were actually what got me into it. And I've talked to a bunch of them about it. I'm always really excited to hear what they're doing. But I think they picked the wrong bug because hissing cockroaches are some of the laziest bugs you can work with. My students call them the sitting cockroach because that's actually what they do. They just pretty much sit around. So I'll be sharing some of my data with them, I think, in like May, and I could be like, y'all are doing good, but you should have picked. Look at all this data you can get from this bug. Know your species. Don't assume stuff, et cetera, et cetera.
That's awesome. I can't believe you did a spreadsheet of all of the different cockroach species. That must have been a lot to learn about all of those different.
Yeah, it was. I mean, it wasn't all of them. It was all of them you can get in the hobby. Hey, by the way, I can't remember if it's Australian or New Zealand, but rhinoceros cockroach there. If you can find them, they're worth about $200 to $500 a piece.
All right.
If anybody in your neck of the woods really wants to look into that. I tend to get like a little obsessive about things, which is you got to know your own behavior too and how you are. There's pros and cons to that, and I do my best to work with the pros and move past the cons. But yeah, it was a lot to learn about.
You said generalizations are there to help us out in the absence of information.
Yeah.
I love that. It works really well until it doesn't.
Yeah, that's life, man, right? I mean, like...
I love it. I was going to say that's a good enough quote by itself, but I think you just added to it then. Generalizations are there to help us out in the absence of information. It works really well until it doesn't. That's life, man.
Yeah, well, let's put it on a T-shirt, right?
Hey, I don't think we mentioned it yet. Can you tell everyone how to find your website and get in touch?
So my website is cavarnon.com. It's just my name is Christopher Allen Varnon. I'm not hiding my middle name. I'm an academic. I'm proud of it. We got it listed in places. So you got my website. You can find a ton of stuff there. I'm working at Converse College, so I have. If you Google like Chris Varnon Converse College, you'll find my Converse College webpage, which doesn't have a whole lot on it. Really, if you want to know more stuff, I'm always intending to do more with social media, but I don't really. Just send me an email. I think your listeners probably realize I'm happy to talk about stuff. So like send me an email. That's reinforcing to me. So like I'm happy to chat about whatever thing. It's always fun to talk about behavior analysis.
Wonderful. Well, thanks so much for sharing everything today, Chris. We've been going for just over an hour now, but there's still a ton that I'd love to pick your brains on.
Well, I'd be happy to chat more.
Yeah, well, we mentioned potentially already in this episode and when you and I caught up beforehand that we're going to continue this conversation in our next episode. And we wanted to talk more about comparative psychology. Is that the correct second word?
Yeah.
Comparative psychology?
Yeah, comparative psychology, yeah.
Which you've briefly touched on at various points in today's recording, but we'll unpack that more in part 2. So we'll leave it there for today. This has been a ton of fun so far, Chris. We're super grateful for you taking the time to come and hang out with us today, and we can't wait for part 2.
Of course. Thanks for having me.
We do, of course, really appreciate all of you tuning in today as well. And if you have enjoyed this episode and you were interested in carrying on the conversation about working with our animals in the most positive, funnest, choice-rich ways, then as mentioned at the start of this episode, the Animal Training Academy community is waiting for you. Head on over to www.animaltrainingacademy.com and click on the membership button in the main menu to learn more about what members are describing as the Netflix social media platform for behavior geeks. That's it for this episode though. We're going to wrap it up there. Thanks again so much everyone for listening. You'll hear from us again soon.